We are given a circle equation and a tangent that touches the circumference of that circle at P. So we want to find the area of O, A, B, O is the origin, and B and A across the X and Y axis. So we're going to rearrange the circle equation to find some details. At some point we have to find the X and Y value at A and B. So we're going to complete the square, and we'll be able to find our center and our radius where it may become relevant. So I'm going to complete the square now for this equation. So you'll get a center of 3 and minus 2. That's from what we have within the brackets there. And putting our constants together, we'll get root 40. Okay, from there, I've already put in a dot for our center of the circle. We will want to find the gradient . So if I do a line there from P to the center, that would be, again, like negative reciprocal, the perpendicular gradient of A and B, from A to B. So if it's 3, then it's minus 1/3. So that's our gradient there. So the equation of the tangent would be y minus 4 is equal to minus 1/3 bracket x minus 5. And we want to find out where x is equal to 0 and where y is equal to 0. So where x is equal to 0, we find b, or at least one value, the y value. So for x equals 0, y minus 4 equals 5 over 3, so y will be equal to 5 over 3 plus 4, which is 17 over 3. And for a, 0 minus 4 is equal to minus 1/3 x plus 5 over 3. So minus 1/3 x is equal to minus 17 over 3. So 17. So x is equal to 17. At this point now, you can find the area for OAB because we have 0, so that's our origin. Our y-axis, we have 17 over 3, and our x-axis, we have 17. So for the area of a triangle, 1/2 times those two values. So 1/2 times 17 over 3 times 17, whatever order you want. And the answer is 289 over 6. So that's that area for part A. I'll just check just to make sure before you move on. Part B, we've got points Q and R also lie on a circle, and we have PQR as an equilateral triangle. That will be helpful. Let's rearrange our diagram now. So the area of PQR, we're going to have to divide it up in certain ways. So there's our equilateral triangle. Just remember, like, if we're dealing with radians or degrees here, have your calculator ready. And remember that we can use trigonometry here. So we know we're 60 degrees, or cosine 60, cosine 30, something like that here. So I'm dividing up into a series of triangles, and we just need to use one of them, or even half of one. Actually, we're just going to use half of one, and you can then of course multiply by 6. There's 6 of them. So we already know our radius. And we can, just the knowledge of an equilateral triangle, we can say we have cosine 30 and cosine 60 at the top, if you will, of that yellow triangle I've just drawn. And you can see on the right hand side I'm drawing that up anyway. And it should be pretty much the same as the previous question, just we have to be careful here with these details. Let's put that down there for show. And that's clear, isn't it? So 1/2 root 40 cosine 30 degrees times root 40 cosine 60 degrees. You can simplify from there, you'll get root 30 and root 10. And that's one of those triangles. So remember to multiply it by 6 and you'll get an exact area using surds here. So we have 30 root 3.